Hello, my fellow mathematicians. Today we're going to talk about transformations. So there are three types of transformations. Those are reflections, translations, and stretches/compressions. So no, really there are 6 types of transformations because there's a different rule for those 3 for the x and the y-axis. So that's what we're going to talk about today in this video. So let's begin. So let's start off by talking about reflections. So you can probably remember reflecting things on a graph to when you were in like 3rd grade, but you probably didn't learn these formulas, and if you did, good for you. So we're going to start off with an x-axis reflection. So an x-axis reflection is negative f of x. So this negative sign applies to both the f and the x. So for our example, we have x squared minus 3y, just because that's a fun number. And we're going to make that whole thing negative. So we're going to make this part negative and this part negative. Now you're saying, oh, well, that's positive, so why are you saying it's negative? Well, because clearly negative 3, and you're subtracting negative 3, so negative and a negative makes a positive, so it's negative x squared plus 3. Now, for our y-axis reflections, we have f of x to f of negative x, and that's in parentheses, and it's really important that we remember a parentheses for these formulas in general. So if we were to take x squared plus 5 and reflect it across the y-axis, we would just make this part negative because y just has one negative, so it just becomes x squared minus 5. Now, a simple mnemonic I use to remember that there are 2 negatives in the x-axis reflection and just 1 negative in the y-axis reflection is pretty lame, but I'll tell you all anyways. So an x-axis, it's pretty, it's like straight and it's kind of wide because it goes like a long way. So it's very sad because it feels fat. While y is just a little sad because, hey, it's skinny, but sometimes its tallness gets it kind of sad sometimes. So that's why there's still just one negative. But it's better than being like super, super duper short and very fat and long. And I know that's kind of dumb, but I don't know. It helps me remember that. So now we are going to move right along onto translations. So you probably remember translating shapes on a graph in your previous younger grades. But now we're just going to have to memorize a formula to do it with a quadratic. So let's start off with horizontal translation. So with the horizontal translation, we take f of x, and it's going to become f of x minus h. Now, these parentheses are really important to remember because these, as we're going to see later, are having to be together. So if we take the parent function of a quadratic, which is x squared, and we take a horizontal shift to the right by 1 unit, so we're just going to subtract 1, we have x minus 1 squared. So like I was saying earlier, it's really important that you remember that these are in parentheses because now the x minus h are together, and the squared applies to both of them, so it has to be on the outside of the parentheses. Alright, so that's why it's super, super duper important to memorize these and where the parentheses are. Now for a vertical translation, we're adding k. What's k? It's just what we're moving it by. I don't know why it's k, just don't get confused by it. So we're adding k, but it's not within the parentheses. It's going to be on the outside of the parentheses. So for this specific example, we have x squared minus 7. And then we're going to take x squared minus 7 plus 4. Now this plus 4 only applies to this minus 7. It does not apply to this x squared. So x is going to just become x squared minus 3 because you're just going to combine these two. I hope that makes sense. Just to recap, we're going to, for vertical translation, we add k on the outside of the parentheses, And for a horizontal translation, we subtract h, which is just what we're moving it by, within the parentheses. Last but not least, we have our stretches/compressions. So stretching and compressions are just pretty straightforward. Stretching, obviously, we're making it larger, and compressing, we're just making it smaller. So let's start off with some horizontal stretches and compressions. So the formula for this is f of x to f of 1 over bx. Now it looks kind of confusing, but I'm just going to use our example to explain this. So if we have the parent function of a quadratic x squared, and we're horizontally stretching it by a factor of 3 over 2. This 3 over 2 right here is b. Okay? So it's really important that even though this is a fraction, we need to remember that 1 goes above that. So it's 1 over 3 over 2 essentially. So x squared becomes x squared parentheses 1 over 3 over 2 parentheses. So once we simplify that, it just becomes 2x squared over 3. So that's basically what you're doing there. It's pretty easy if you just memorize. That's what you do. Okay, so for our vertical stretches/compressions, it's a mouthful right there, we are multiplying a times f of x, and a is our factor by which we're stretching or compressing it. So if we have x minus 1 squared, and we vertically stretch that by a factor of 2, we're just going to multiply 2 by x minus 1 squared. Now, again, parentheses are really important in this because we know that a is outside of the parentheses, so it's not going to be within it. So we're not going to distribute this and make it all confusing for us. Just remember, when we're doing these formulas, we're usually just leaving it how it is and keeping it pretty simple. So don't get too fancy, because that's what I like to do, and it screws me up a lot. So those were our stretching and compressing formulas. It's fun to say. You should try to say that a lot. It becomes a mouthful, I promise. So when you're stretching and compressing, again, you're just making it larger or smaller. Now that we have memorized, or just learned about if this was all new to you, our formulas, we are going to take a quadratic parent function, x squared, and apply several of these formulas to it and see where it gets us. So we're going to take x squared, and we are going to move it 3 units to the left. So we have to remember that when we're going to the left, it's going negative, because if you just have to remember our graph, and the left side is negative and the right side is positive. So if we're moving it 3 units to the left and we're horizontally translating it, our formula here is f of x minus h within the parentheses. It's going to become x plus 3 squared on the outside of the parentheses. It becomes plus because we have negative 3, so we're moving it 3 units to the left, so it's negative 3. And then we're subtracting negative 3. So a negative and a negative makes a positive. So in case you were confused by that, which I really hope you weren't. Next, now that we have our x plus 3 squared, we're going to vertically stretch it by a factor of 5. So our formula for vertically stretching something is a times f of x. So we're just going to take 5, which is a, and multiply that by x plus 3 squared. And like I was saying earlier, we're just going to keep it simple. We're not going to distribute it, and you're just going to leave the 5 on the outside of the parentheses. Right? So for our last step of this particular problem, we're going to translate it vertically by 4 units. So this doesn't really specify what we're doing, but we're just going to move it 4 units up. Alright? We're going to take our formula, which is f of x plus k. And we remember that 4 is what we're moving, and I decided just now that it's going to move up, so it's plus 4. And remember, since this k is outside of the parentheses, we're going to leave that outside of the parentheses and keep it simple. We're not going to add it to 3, which is really tempting, but I promise it's a bad choice, and you should follow the rules and leave it outside of the parentheses. So hopefully if you're doing this on your own, you got 5x plus 3 squared plus 4. So that's all of our transformations for today. I hope you can memorize those formulas and totally rock.